Welcome to the Construction Show. I'm your host, Jared Downey. Today we have a first-time guest on the show, Leo Liu. Leo, you're the first person I met with two. The first and your last name are the same, spelled different but the
Yes,
same.
yes. The first name and last name are pronounced exactly the same, Leo Liu, and so I just go by Leo,
You just go
and
by Leo. it's,
yes.
well, I wanted to clarify because so the audience didn't think I just repeated your first name twice. But no, welcome to the show. You're the director of mapping solution at Inertial Labs. I'm going to have to keep up with you. I know you've got a lot of technical knowledge. The technology is fairly new, so I'm just cramming to learn about it before the show. So I will try to keep up, but please don't wait for me. Just dig in.
Not a problem. Yeah, thank you very much for having me here, Jared. It's been fun being a fan of your show. It's great to be here, and I really appreciate the opportunity. Thank you
Yeah,
very
thank
much,
you.
though.
Where are
Yeah.
you located?
Oh, I'm based out of Berkeley, California, and we're across the bay from San Francisco in case we have international audiences who are not familiar with the area.
Yeah, that's that. I mean, there's a lot of development coming out of. I'm guessing you're developing a lot of this technology, right? I just want to clarify to the
Sure.
audience. We're talking. You are the actual producer of it, not you're not a distributor or something like that. Is that correct?
That is correct. That
Yeah.
is correct. And we are in general still a very young technology in many ways. And but you're exactly right. One of the reasons I'm still staying here in the Bay Area instead of moving to join the rest of our team in Virginia is because as many know, Silicon Valley really is the center of technology. Is in our field in lidar mapping, sensor fusion mapping. There's the new stuff coming out on daily basis, so it's very important for us to stay current on what's happening. And so that's why I decided to stay around here and work remotely.
I feel like I could be keep digging on this topic, but you are here to talk about inertial, so I will stop myself because but it
Sure.
is a great topic. We maybe will reference it later on though to tie it in. So inertial. Well, how did you end up with Inertial Labs? Actually, no. Sure. Well,
That
actually, first let's give an overview for the audience. What is Inertial Labs? Let's give a little bit of background.
Of course. Now, Initial Labs is a company came out of Virginia Tech, actually, and we are headquartered in, let's just say, Leesburg, Virginia. And we've been around for 20 plus years. And the company's core competency is in navigate advanced navigation sensor and navigation solutions. Now, sensors meaning a little bit of little device. So what that gives to give you is your speed, your position, and your orientation. So this is important when we get to talking about some of the products later on. So that's Initial Labs' core competency and core business. And for us, I run the team RESEPI, which stands for Remote Sensing Payload Instrument. And we are a relatively young team within Inertial Labs, and we are focused on sensor fusion, mapping, inspection, and navigation solutions. So we are almost like subsidiary of Inertial Labs. But yeah, that's a general kind of introduction of Inertial Labs.
Let's talk about our heavy industry world tour brought to you by Savannah Equipment, supplying mining equipment worldwide. We are heading to events across North America and Australia and filming episodes on location. Email us at info@crownsman.com to be part of Crownsman's Heavy Industry World Tour. Studs and helmets use cutting-edge head protection components used previously only in extreme sports helmets, now utilized in both of Studson's Type 2 models. The SHK-1 and SHK-1 full brim models are the most innovative helmets on any job site. Offering a revolutionary combination of Koroyd and twice-me technologies, this Studson full brim helmet is the first of its kind in the Type 2 category, providing you with the protection and comfort you need to get the job done. Saving lives one helmet at a time. Studson, where safety meets innovation. You can visit them at studson.com to learn more. L&H Industrial can custom engineer and build from the ground up any heavy equipment assembly or machine that you need for your operation. Their worldwide 24/7 field services network is on the job whenever you need heavy equipment troubleshooting, repairs, rebuilds, relocations, or replacements. And thanks to their specialized design and engineering and state-of-the-art manufacturing and repair services, they are a go-to international supplier for improved components and custom assemblies for heavy industrial machinery. Visit lnh.net to learn more.
Okay, so the side that you're handling is I've got a note in front of me. So RESEPI, right? Remote Sensing
Yes, sir.
Payload Instrument. Can you break down can you break down the actual technology itself? Now, is the technology itself that's not new, right? That's been around. So maybe just let's just give an overview of the technology itself, and then we'll go over to RESEPI after that.
Okay, so the technology, are you referring to the technology, what, inside RESEPI or inside Inertial? They're two very, very different.
Inside RESEPI, I think we'll focus on. Yeah.
Gotcha. Gotcha. All right. So now RESEPI, the name is very interesting, remote sensing payload instrument, but the technology it presents and it offers as a product is all the technology inside RESEPI. Most of them have been around for a long time. Now, what exactly does RESEPI, something like RESEPI do? And many might have heard another name, just LiDAR mapping payload or LiDAR scanner. In the
Hmm.
construction business, many probably have seen those static scanners like Trimble, that it's on a tripod. You see
Yeah.
that thing spinning around, shooting laser. So that's one type of manifestation of the technology, but Recipe is slightly different. We are a mobile solution. Now, if you break it down, what's in Recipe? Now, on the data capturing side, first let me say this. It's almost like a little robot that moves itself and capture data
Hmm.
as through some sort of sensor. Now, let me break that down. So for now, the primary data capturing sensors used in a recipe type of solution are typically two. That would be laser and camera, RGB camera. But technically, you can pretty much use any data capturing sensor like multispectral, hyperspectral, thermal, radiometric, all that stuff. It's really doesn't really matter. And then the other side of it is about navigation or positioning. Now that's where Inertial Labs expertise come in, and because this thing needs to move. And for now, there's a planned trajectory to move, but in the future, which is when things get really exciting and interesting, is that thing moves itself. And that's where we're focused on. But inside this navigation component, sometimes it's called the POS, POS, the POS module or nav box, NAV box, navigation box. All kinds of different names for it. So that's our core competency in Inertial Labs. Now, inside the nav box, in order to move, you need to know where it is and then decide where to move towards next. So, going even deeper, what Inertial Labs is really good at and been doing for the last 20 years is to help that device to understand or know very precisely and accurately where it is and which way it's facing at any given moment at very high frequency.
I
And
want to, sorry,
yeah.
I just want to get some clarifications on it. Like, let's go actually step back, take a step further back from Inertial Labs, because they're in all sorts of industries. Where did they, um, can you give us some for where Inertial Labs, some of their key components um, before Resepi came on board or online?
Hmm.
Where
Sure.
can you set up a couple applications where their systems would be used? Like I've seen stuff like the military stuff. There was all kinds of things you had. So can you just give us a couple like examples, just so we have sort of a real world example?
Of course. Now, National Labs core competence again is in navigation sensor and
Yeah.
navigation solution. Now, and what that technology or product does is telling and letting you know where you are. So, use case, the easiest one to understand is your GPS on your car. And that's really ultimately it is. But what's different with the initial lab solution is besides when we talk about GPS on cars, there's only GNSS, that's satellite-based navigation.
Right.
So it's only GNSS, but what's different or what's better, in the initial solution is we have something called IMU, initial
IMU.
measurement unit, IMU, initial measurement unit, that
Okay.
comes in. That measures your acceleration at very high frequency. By acceleration, we are talking about both angular and velocity. So it's measuring the device and how quickly it's changing speed and in which direction. That technology being used in the commercial sense from cars, robots, anything that needs to understand the status, or the state of the movement of that device. Or, in the military side is to measuring, whatever like weapon systems or submarines, its state
Like
or
the
its
like the
use.
when you're saying weapons, you're talking weapons or submarines or things like that. You're talking about the stabilization of the device.
Stabilization, yes, anything that moves and shakes. So
Yeah,
this technology tells you exactly which way it's facing at any given moment
yeah.
at super high frequency.
And what is that based off? Is that based on like some how is it understanding? I know that we're not going to pack up the whole science behind it, but
Yes.
what is there
So
sort of a overview of how that works?
yes, the way it accomplishes that is through a sort, I mean, a setup of multiple little sensors within that measures different things, and those, let me put it simple way, those sensors, whatever, through the technology itself is going to tell you basically how your device moves.
So it's almost
That's
like
all.
a grid sensor. Yeah.
Yes,
Okay.
yes, and so that's ultimately is what it does, and the rest is about his performance and the grade, all that stuff, and
Okay. So
it's
then,
literally
oh,
everywhere, and anything that moves. The,
that it can be applicable for.
our
Okay.
phone, our phones have IMU in there as well today.
Right.
That's why, it knows, when you take a photo, for example, oh, it's facing this way. When you rotate it, you see the photo, the camera app rotates it. So it's the same technology, essentially.
You know what? I've never been told that. So that's one of those things. Someone like yourself, you would just know that innately. But for me, I would have thought that that was actually some sort of computer. I wouldn't have thought of that as a sensor technology. So this
Yeah.
phone is actually sensing it.
Yes.
With Fender Dunlop, you know you are getting the best conveyor belting in the market. That's because they ensure the integrity of their conveyor belting by monitoring each step of the manufacturing process in their North American facilities. Focused attention is given to each belting order to guarantee that they produce a belt that will assist the customer in reducing operation costs, maximizing uptime, and improving revenue. Visit FenderDunlopAmericas.com to learn more. Reduce tire related production interruptions and enhance vehicle safety with Doran tire monitoring systems designed for off road, earth moving, and industrial equipment. Real time access to accurate, reliable tire pressure and temperature information helps operators and supervisors maximize equipment performance and tire life. Doran tire monitoring systems are designed to withstand extreme operation conditions while featuring simple installation and low maintenance. Visit DoranMFG.com for more information on how Doran can help reduce equipment downtime and improve safety. Dayquip specializes in the design and manufacturing of attachments for all makes and models of compact excavators, wheel loaders, crawl dozers, and articulated dump trucks. You can choose from any of their engineered attachments, or they can design and build to your specifications. All of their products can be shipped anywhere in North America, hassle-free. If you don't see it, just ask and they will build it. Check out their website, www.dayquip.com, or email them info@dayquip.com for sales, quotes, and support.
Okay, so now with that technology, now does that, and I know I'm sort of getting you to repeat yourself, but I'm just trying to kind of piece it
No
together.
worries.
So now that technology gets transferred into RESEPI, is that right? And now
Yes,
other
sir.
technologies get so this device now knows essentially what is a balance point. Is
That
that
yes,
right?
what we try to capture for RECEPI through this sensing technology is not about to stabilizing it. It's rather it's to know very precisely at any given moment which way that device is facing. Uh,
Okay.
and that's what we need to know through this technology. The more accurate, the more precise we know the system orientation, the better the derivative products coming from Recipe will be.
Okay, so you've got the technology that gets it essentially facing the right way, it, very precisely.
Very
Now
precisely.
you start tacking on what technology to make this device do what you want it to do.
Yes, once we know where this device is and which way it's facing, now, let's bring in additional sensors like laser. Now, laser shoots out lasers, right? So, and this technology ultimately to the end users or end customers, what they care about is the capturing of that 3D environment,
Right.
where things are and then what they are. So with laser, what it does is literally a range measurement. So laser shoots out laser just like lights and bounce back a signal and then tells you all you know is okay, this laser traveled, let's say 500 yards in this direction. And that's all it tells you. But then because our pose module, that's where our core IP comes in, we know where I am, right? So you visualize the light shoots out from here in that direction, 500 yards.
Yeah.
And now I know where I am and which way I am facing. Now, you do the math and you tag that on, you know now exactly where that point is.
Right.
Does that make sense?
Yeah, no, it
So,
does. It does. And when you're saying laser though, these are I would assume millions of laser points, right? Hitting one
oh
surface.
yes,
Yeah.
it's amazing. That's another thing when I get to, when I talk about things like this, just it gets exciting. And
Yeah, my
you,
job is to get people started on the show. That's literally
It's
my
it's
only job.
it's easily millions of points per second. And there are sensors. I mean, I shouldn't say easily, but there are sensors capable of shooting out millions of pulses of laser per second. It's pretty
So
crazy.
it's almost like if it was water, it would almost be like a wave that formulates around, but it's laser. So now it's sending it back to show the shape of whatever it's basically masking.
Yes. Yes. What it does is, really shoots out pulses, almost like shining a torchlight,
Yeah.
shooting out a lot of pulses at very high frequency. And then, because every pulse will bounce back
Hmm.
a few points,
Yeah.
registering something out there in some direction and some distance. Once you have millions and millions of points captured, then you start bringing those points together. You start build that understanding of your 3D environment.
Right.
Again, the key here is very accurate and very precise.
Yeah. And now, okay, what's the next piece of technology tacked on?
Once we do that, and then the next, that's the hardware side, sensing and capturing the
Yeah.
raw data points. The next piece of technology is steering navigation side and a little bit of the point cloud side. Point cloud refers to the laser data points captured, right? So it's about actually converting that raw data in software into usable or standard in industry standard data format for consumption down the road. So that's software coming in different ways to do that, and we have our own way to do it, obviously. And so that's the next piece is to resolve that raw data set by bringing all this different raw sensor data, the camera, the laser, the IMU, the GNSS, and all that, and basically resolve all that raw sensor data and produce that consumable industry standard format then it can be taken to somewhere else for processing. So that's the second phase.
I guess I should clarify who is your client? Is it somebody that's going to now it, let's say someone has a construction site that they want, or I saw some great footage of you actually going along a river and doing like a forest. We can get into some of that. That's
Hmm. Hmm.
unbelievable. But doing stuff like that, is that um, is that a technology, or is that a like a company that delivers that sort of service, and then they're buying your product, or who is the actual, like, who's the person that you're talking to?
Excellent. That is an excellent question. I think we're in a transition stage, and our the I'll go backwards, and the customers actually who really utilize the fruits from the technology are the actual data users, like construction companies. They use the data to understand the progress of a construction project, or forest service, and using that data to understand, okay, what kind of trees do we have, how tall they are.
Yeah, yeah,
But what's interesting is in some markets, and by markets I mean in this case I'm referring to countries because of business kind of how business is done, like in the U.S. most of the data capturing and even data initial process are actually done by service companies. So they end up being our customer,
Right. Who are
even
then
though
dealing
the
with like a forestry company or a
correct,
construction company. Yeah,
correct,
okay.
correct. So yes, so we are dealing with service companies mostly.
So yesterday, as I was cramming for the interview, I was looking at your models, and now I have a better understanding of actually what they do. So, quick clarification: all these models that I was looking at on your website, they all do somewhat of a similar thing, right? Okay.
Yes, sir.
So, can you maybe just pick out a couple of them? Obviously, we're not going to go through each one, but maybe pick up a couple, out a couple, and then just if you can, just give us some applications where this would be the right fit based on this unit.
Of course, this is a great topic now. So if you look at, for example, the two on the top of the list, Ouster and Teledyne, right? So as we went through the fundamental structure or composition of technology already, so they're essentially the same. The difference between these two models really lies in the laser. So whatever the laser can do, determines which is good or better for what use case. In this case, for example, you look at the difference between Ouster and Teledyne. These are two different classes of laser, right? The Ouster is small and light. Typically, personally call this type of laser the auto class laser. They came out to the market very much thanks to development in the self-driving industry, which now utilize a lot of these little lasers. But Teledyne is what I call the classic laser. They're typically bigger, larger, but much higher performance. When we see performance for the lasers, we are primarily looking for the measurement distance capability, accuracy, precision, and there are a few others like number of return. Like we probably don't need to go there. So that difference in the performance and determines which one is the right one for what. Obviously, with different grades of performance, it comes a difference in cost. That's always a key factor for any customer to consider, and actually a key factor for technology adoption in general. So that will be the difference. So, but fundamental technology is the same. Yeah, you
Well,
sorry, keep
actually,
going.
I just want, okay, so let's say somebody wants, okay, so they've got a budget that's for this type. What would an example be of that, of the less expensive one?
Mm-hmm.
And now
Mm-hmm.
what would be an application where, no, no, you need this. You need this type of, um,
Gotcha.
I'm
Yeah,
stumbling
gotcha.
everywhere, but I think you know
No,
what I
no,
mean.
no,
Yeah,
no.
yeah.
That's good. That's good. Yes. Because the key difference between the laser light, lie in measurement distance, measurement accuracy and precision. And then for some customers, it's a number return. Number return is a tricky one, and which really means is how many data points a single pulse of laser can actually register. We can go deeper if we need to, but let's keep it that way. So and for customers in general, it's really the higher performance, the better. But there's some cutoffs or threshold which basically will dictate you have to go with something better. For example, the Ouster laser has an effective measurement range of somewhere around 90, 100 meter ish, or that
100
goes
meters.
to
Okay.
yeah, so 300, 400 feet ish. But the Teledyne laser can go up to hundreds of meters, so thousands of feet. So right
Wow.
there, if you have some project that requires the system to measure from, let's say, 250 meters away, then you really have to go with the Teledyne, and the
Right. So if
Oscars
you're
are
doing a
cut.
warehouse, you then which one's the smaller one? The smaller range? So
Ouster is
ouster.
a
So an
smaller.
ouster
Yep.
you could do maybe like a little residential area or something like that. If you're doing a forest, now
Yep.
you're going to
Yes,
which one?
that's a good example. And also measurement precision and accuracy can be a dictating factor as well.
Right.
So the Teledyne has it can measure at much higher level of both accuracy and precision. So that could be important for some project, for example, if it's engineering focused, where
Mm.
you need to define like the edges and corners of some little feature as well. So that may require the laser to be a lot more precise in its raw measurement.
So
So some things like that.
this will be the accuracy of the measurement, but also will that be like the graphic that you get back? how detailed that is? Will that be,
Yes.
yeah, so that's all
Yes.
included. Okay.
If it makes sense, I'll use an analogy like camera, right? With camera, we have different image and sensor resolution. Is it 12 million pixel, 60 million pixel, 100 million pixel? In a way, it's similar. So we have, just like you have a higher resolution camera, you take a photo and compared to that taken by a lower resolution, action camera or something, right? And then you compare the images. One is much clearer. The other one is it doesn't offer as much details. So it's
It,
the same thing.
and now, would these be attached? Now, these are getting attached to different things depending on the application. Then, like that
Uh,
one with the forestry, I'm assuming that was attached to some sort of drone. If you're doing something residentially, maybe put it on a tripod. What is there sort of? What's the configurations that the devices will
yes.
get mounted on?
Yes, and that is an interesting topic, and also actually a key differentiator between our product recipe and some of the others. Yes, the sensor itself, technically, it's carrying platform agnostic. What that means is
Okay.
for our sensor to work, it doesn't really matter that much if it's a drone, small drone, big drone, even airplane, or it's a car, or it's a backpack handheld, or a robot like a Spirit from Boston Dynamics. You can put it on that dog as well to move around. So, and you're exactly right. Exactly what is that deployment, form? It depends on the project and the environment. Sometimes you have to fly, sometimes you have to walk, sometimes you need to drive. And so, that's really depending on the project. But most of popular deployment form these days, today, and I would say it's aerial. It's either on drones or on airplanes. And then MMS on cars. MMS, it may come up a few more times. It means a mobile mapping solution or mobile mapping system. And so on cars or on drones or on airplane, those are the more popular
Mm,
way of utilizing this technology. But what's really picking up now is on backpack and handheld, like you just mentioned in warehouse. How do you scan a warehouse or construction site?
right. Yeah.
Uh, yeah. So
It's well, I guess I should clarify if you were like doing interior and that are you getting like measurements as well? Are you getting imaging or because you said about the precise of like distance and that. So are you getting does that data get provided? Is it possible to get the data for measurements, things like that?
that is the beauty of laser. And obviously through camera only there's technology to do that as well.
Yeah.
But yes, the
So with
one of
these
the
is precise.
is very precise. It can measure and uh very precisely the dimension, size, depth of 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 uh, of things within that environment through laser scan point cloud. And yes, images as well. And the technology is been around for a while. Basically, using casual way to describe it is you can literally we could colorize a point cloud through camera image. You literally just drip that RGB photo onto that 3D point cloud.
Mm.
And so, yeah, you could have colorized point cloud, which is actually quite helpful for some use cases.
The a question I'm as we're going through it, I go, where how old would this technology be? Like kind of first
Ooh,
versions of laser technology and even any sort of image mapping from it.
of course, so all three sensing pieces, navigation, laser measurement, and camera imaging, they've been around for a very long time. And like navigation, GNSS, and all that stuff's been around since 60s and 70s. I think it's
60s.
around the same time.
Yeah.
Laser technology is the same thing, right? It's all
Yeah.
around that
Yeah.
time frame. A camera is probably even much
Yeah,
older.
yeah.
Oh,
Yeah, it's
yeah.
just
So
it's I mean, really in
yeah,
the history of the world, it's not that long, right? Like as a
correct.
species having the technology.
Correct. So
Um
the adoption or fusion of this different technologies into something like RESEPI is fairly young. I would say, if I remember it correctly, the first form of adoption is actually mobile, so on cars,
right.
because back then the lasers were pretty big.
Right.
And so I think the MMS was it was likely or maybe aerial as well on airplanes,
Right. Yeah.
primarily for military use cases to scan some terrain or some area. Those are
Right.
first, but the newer yeah, the more recent adoption is on drones, on robots,
Yeah.
or handheld and backpack, as the different sensors become much smaller, which made it even feasible or possible to deploy the technology on those newer platforms like small drones.
Yeah.
And back in the days, you need a big airplane to fly and to carry those laser sensors. But today it's amazing. We have sensors that's less than 1 kilogram in weight. And it's very light, and you can carry that full payload in a lot of small drones.
Wow.
That just really helped the adoption and pushed and drove the use of technology across more and more use cases.
I was thinking the military on the military side, what they're able to do now must just be unbelievable to be able to map out. Because I mean, moving assets in the military is one of the biggest, obviously risks and costs and all that sort of thing.
Yeah.
It must be
What
incredible what they're able to actually map to move. I mean, I'm not I'm not commenting on military
No,
actions. That's not what I'm talking about.
absolutely.
But the
It's a
logistics of it must be absolutely incredible.
Oh, absolutely. That's actually, is directly, it's no different from the number one use case today with this technology, which is topographic mapping.
Yeah.
Now, and in other words, you look at this example I'm looking at right now, it's about 1,000 acre of land
Oh,
that was flown with a fixed wing aircraft with the one-valve payloads on it. It's about 2 hour of flight with drone. Again, it's about 1,000 acre. And if you have the computer software, everything on the same day, you can produce a beautiful topographic data set.
amazing.
And with all the trees, houses removed, now you see exactly what that topo looks like. And what's really amazing these days is because thanks to the advancement in all the sensor technology from navigation to laser itself, you are actually able to achieve reliably very high level of accuracy. And I don't want to throw out any specific numbers because that may trigger some to argue, and I hate to jump in
Well,
those
that's good. That's
arguments.
good online. I mean, for online activity.
Yeah,
No, I'm kidding.
but let's just say you can reliably achieve survey grade accuracy that meet the need, or requirement of typical like a construction project with no problem.
I see.
This is 1,000 acre. Imagine in the old days how it was done is sending surveyors out,
Yeah.
and imagine, just do the quick math. Okay, how many days you would need a group of surveyors to be out there
Yeah.
doing that survey to capture that 1,000 acre
I have a
site.
bit of an old soul, so I can just imagine the feeling of of a surveyor as a drone floats by them as they're walking with all their stuff going now. I guess
Oh yeah.
this is
Uh,
these days are coming to an
another
end. But
another
yeah.
use case on the other end of the spectrum in terms of the use case, right? And so there's a big trend. Many might have heard the word digital twin.
Yeah.
It's really about capturing everything around us,
Yeah,
and
we've
there are
done episodes
countries.
about it. Yeah.
Oh yeah, there are countries out there establishing national policy to digitize the whole country, right? One
What?
tangible use
I
case.
hadn't heard about that.
Oh
Really?
yes, yes.
Whoa.
And
Okay.
that that kind of national policy have huge impact on the development adoption of technology. And countries like Japan, China, even Korea, they are quite a bit ahead in terms of digital twin, right?
Digital
For example,
twinning the entire country.
no
Wow.
joke.
That
And for example, China, like for I believe it was 5 years ago, I could be wrong that one, and released a national policy which literally called for the digitalization of the whole country. Uh, and that in turn drove a lot of new startups in that country to
I bet.
jump in that world. And then the rest of everybody can see how that works out
I feel
when
like
you
in
when
the
you
US that would get some pushback.
Yes. And US get the US, one example for this technology is, say, we know after 9/11, there's it becomes a lot more, recognize the need for better data set to understand the environment. For example, we have in San Francisco, or New York, we have a lot of 100-year-old buildings, right? Those buildings have been around forever. And so do we really know what's inside those buildings today?
Hmm.
We don't. So, and there's been so many remodeling and, tenants changing things. So
Right.
we don't
Just
really know
you mean
what's in
structurally? What
structurally.
as this
Yes,
building gets pieced together over years and years?
correct. Now
Yeah.
the question is, if something happens, there's a situation inside the building before, let's say, the firefighters go in or the police sending a SWAT team. How
Mm-hmm.
do you plan that mission?
Yeah.
And we see a lot of this kind of sense in movies or TV shows, like say,
Right. Yeah.
oh, the police is gonna bring up on the screen, oh, like that fancy 3D
Yeah.
visual of the interior. So okay, you go from here and you plan your attack, route or exfil. That's the data. That's exactly what the data is about.
Yeah.
But in reality, its data is not such so readily available. And
Right.
but guess what? You can either send out surveyors to measure and build that data set, but you can send out a robot with sensing technology like RESEPI, and they can one exciting future. Sorry, I'm getting a little excited to talk
No,
about the
no,
future of
it's
technology.
very interesting.
And so in the future, some of us, or we see is you have a little robot, we call the, dog in the cage or drawing a box, right? So, let's say you have a big, the Millennium Tower in San Francisco or something. You have, in the corner, the basement, you have a cage there. Inside the cage, there's a spirit, something like Spirit Boston Dynamic, the robot dog, and it carries a little sensor like Recipe. And every night, midnight, that thing's gonna come out by itself, and it's going to walk around that building, and through the sensing technology from a solution like a RESEPI, it's going to capture laser points, build a point cloud, capture thermal, capture camera, and whatever sensor that's in there. And in real time, that data set will be uploaded into a central server, and even better, and with proper software algorithm, that data is going to be analyzed on a daily basis. So every day when the building manager comes in the morning, he or she's going to look at data. Okay, everything's still the same, nothing changed. And then when a situation happens, the police or firefighters can immediately access that data set. Now they know precisely, oh, we can't go in from here because it's blocked. Oh, there's somebody open up, a door or something here. We can go through this route. So imagine that usefulness, the value of that kind of data set. Obviously, we are still,
Yeah.
quite far
I
from
don't know
that
if I'm
future.
excited or scared now. I don't know quite where I'm at. I'll have to.
Drawing's the same thing, the
Yeah.
same thing.
Yeah.
Drawing a box, it's somewhere, and it's just if you have a construction site, we know, I know we have a lot of construction colleagues in here, and if you have a construction site, your progress monitoring
Yeah.
is quite important. You need to know how is that progress our site, how is that project progressing. So you can have today, you can hire somebody coming in and pay thousands of dollars to do a survey, every, I don't know, month or something. But in the future, you could rent a box and place it at the corner of the
Yeah.
whole project site. You have the control set up. Every day that thing is going to come out and
Yeah.
fly itself
Yeah. It's
and
amazing.
update. So you know exactly how the project is progressing.
Yeah.
Imagine the value of that to a project manager.
Yeah, well, this leads me to my next question. Actually, before I let you go, I have a couple more things I wanted to cover. But the big one is then is the laser technology, and I forget the acronyms for some of the other ones. But the like the RGB cameras, and what's the other one for the actual for
IMU,
IMU?
IMU,
So
yes.
is it about maximizing or integrating into like autonomous things like drones and vehicles and things like that? Is that the next stage, or are there next stages to get for like the lasers themselves, or is that technology pretty much at its peak, or is all of it just going to continue to get better? More powerful, smaller, more compact. What's sort of the landscape over the next, let's say, 10 years?
Oh, that's very exciting. The next 10 years, I do believe a very advanced stage of full automation is likely to be here.
So that's the main
Uh,
technology. It's the automation of.
That
the
yeah,
technology.
that is about the former deployment is a full automation, and I believe me, there are countries out there like Japan where the labor force is dwindling, and a lot of the things there's just no young people coming to do the job anymore. So
Mm,
it's a forced adoption of the technology,
right.
particularly full automation. But at the same time, the development on the sensor themselves will never stop. The lasers, for example, or the cameras, will get even higher
So
resolution,
it's
more
not like a
accurate,
sol like
smaller.
solar panels. They're not, the technology doesn't have 10x to go. This technology
Oh,
is not like that. There is still
oh,
plenty
I
of room.
believe so.
Yeah.
And there's already concept out there that's drastically and changes how the sensing technology works. And then what's even more beautiful, like that's a beauty of Silicon Valley, really, is what can software do on top of sensor fusion, right? Andreessen Horowitz and Mark Andreessen be calling, software is eating the world. And on top of better sensor and better sensor fusion, and then you throw on top of that the software stack, the advanced algorithm, the latest computing power, what you can pack into something like the latest graphics GPUs from NVIDIA. Imagine what that can do. So I don't really know exactly how good it can go, how far we can push, but I can tell you, we'll never stop. We'll
Yeah.
keep pushing and just better, faster, higher resolution, more accurate, more automated. And that's where technology is going
You know
in
where I'm
general.
excited about it is that for home inspections over, like, let's say 20 years from now, maybe not even, you'll be able, rather than like a home, the home inspector, and they kind of try to gotta pretend that they can see what's going on back there. You'll just be able to get a data set of the whole development of the projects. You'll know exactly if builders cut corners, all that sort of stuff will be readily
Oh,
available. You'll just look it up, and they'll no,
yes,
this building is not built right. So no, I'm not buying it. You
exactly.
know.
Yes.
Just before I let you go, um, how did you end up in this industry? Was it, did was it right out of the gate of university? Was it,
Yes, sir, pretty
what?
much.
Yeah.
Yes. I'm dating myself a little bit. So I got my master's degree from University of Alabama. Roll Tide, by the way. In 2002. So I've been around for a long time. And my training was in remote sensing, exactly.
Ah,
Multispectral, hyperspectral. So that is in our product name, Remote Sensing Payload Instrument. So this is my technical background. So throughout my professional careers, I worked for the U.S. national federal government and two other private companies. Besides a detour to the hedge fund side, also in technology, but in the hedge fund side, and I've been pretty much stayed in this industry throughout my professional career. And when Initial Labs offered me this opportunity, and there was not much of a thinking because one thing I realized for a very long time is that one of the unfortunate fact, oh, it's reality is a lot of the players in our markets, they're purely integrators. In other words, they don't really own any of the core technology, laser, IMU, GNSS, camera. They don't own anything. So they're integrators. What that means is they have to buy components
hmm,
from all those regional manufacturers to build their solution. Maybe they have their own software stack. But if you really truly want to innovate and push beyond the
right,
boundary of what's available, you need to be able to control at least one of the core technology.
right.
So when there's a lapse, obviously, the core competence is the IMU, is navigation, which is the core and key and critical.
Yeah, and they're not getting that from some third party. That's
Correct.
theirs,
We don't rely
right?
on others.
Right.
We build our own,
So
and
it's
we
sort
can
of an
push.
environment for you, sort of tying it back to you personally. It's an environment where you are able to push boundaries now at this
Yes,
point in your
sir.
career because you're not sort of hampered by, waiting for someone else's device to come.
Yes, sir. That offers a lot of advantages in many ways from both product development and the business as well. So,
Yeah. How did
yeah.
you decide to get up from, like, out of high school? Why did you decide that route?
Into this technology.
Yeah.
Oh, that's it's that's a longer story. I actually it was accidental. And
Oh,
my top choice was not this. My top choice was computer science, obviously. Uh, my generation was all computer science, and but I couldn't get into it, so I got into urban planning, and from urban planning started adopted something called GIS, Geographic Information System. So I picked the technology side of urban planning, which
oh,
is
I see.
GIS. GIS
Right.
is actually is a user of remote sensing, if that makes sense. GIS is about taking the data and do analysis on top of that. So, and then you go deeper. Okay, how do you get the data? That's remote sensing comes in. So it's about using what sensor and do what. So that's basically the
Yeah.
rest is history.
Well, you like. I mean, I can tell you like this stuff. Like even looking at your background, I can see like those books that you've got behind you. Those are red books. Those are not like I've had people on the show sometimes. I can see. I was like, that book's never been touched. It's a brand new book. It just plays there. I can tell.
And our
And you're
engineer's best friend, whiteboard.
yeah, I can see your whiteboard. I can see the graphic paper up on the top with the sheet beside it with the little notes and
Yes,
yeah.
yes, yes.
So you, I
Uh,
mean, you love doing this. I mean,
oh,
yeah.
absolutely. And I can't say enough. This is again one of the reasons I'm staying in the valley because the things we hear from especially the young talents working in the big tech companies, what the ideas they have, the future they're describing that
Mm,
they want to push towards, it's absolutely amazing. If you think what we have today in terms of technology are so amazing or so scary, depending on how you look at it,
depending on your
wait for
mood, sometimes, really.
10 years. Wait for 10 years
Yeah.
and or even 5 years. It's going to be very, very, very different.
Well, I think one thing that's truly important about technology is understanding it. Because sometimes some things are scary. Some things we have to go, no, that crosses a line here. But then some things that people think are scary, once they understand it, they go, oh, okay, that's actually a really good thing. And so
Yes.
a big part of it is educating and letting people assess it. I mean, the technology you're doing, the advantages of it. I mean,
Oh,
you can't even. Yeah, it's.
that's absolutely right. Using our technology, for example, if you want to look at one side of it, now the use case you look at the examples I showed, is you think you can hide under trees? Forget about it. Besides thermal and other sensors, with our solution, our type of solution, we can remove all those trees, as you can see here. We can see what's under those trees very, very quickly and very accurately. So that's maybe the scary side or something. But on the other hand, the beauty of it, in the future, if somebody got lost in Tahoe National Forest or
Mm,
whatever, and we can fly a drone over it, and we know, okay, this is the fastest route. We can send a rescue team out there to help that person.
yeah.
Oh,
Well,
oh, oh, yeah.
yeah. Well, I think what it comes down to, and I think people forget this, they associate technology with morality, but morality does not is not dictated by the technology. That comes down to the people, and that is true from the technology that was a sword that was developed 1,000 years or 10,000 years ago, or a laser that was developed in the 60s. It that doesn't change. The morality and the accountability of people with authority and
Yes,
all
sir.
that sort of stuff. It is the same principles. And I think
Yes,
sometimes
sir.
we just sort of get that hazy because we see something new and go, "Whoa, you can take away you can see a little ladybug sitting in the forest." That's it. But like you're saying, then all of a sudden for rescue, I mean, how many stories? I mean, I'm from Vancouver. People get lost here. You hear it in the news because it's so thick and it is a hard place to navigate. Um,
And not
no,
only that, our technology RESEPI, because we are just, it's probably worth mentioning, we are not just another mapping payload
hmm,
uh, manufacturers in the market. What we are pushing towards is way beyond that. We see RECEPI, especially with our recent announcement of the second generation, we are pushing towards a future where everybody can build their own sensor fusion, navigation, and mapping inspection solutions much easier.
right,
And so that goes to what I said at the very, very beginning is that future. That future, what is that future? Something that moves self without a human operator to control a planet, something that moves itself and captures the useful data and convert the data to something, some useful information for us, for
Right,
human
and
to
more
use.
accessible, more
More
accessible.
accessible.
Yeah,
That is key as well. More
yeah, and
accessible.
that's the
Yes.
other thing. That's actually a really good point. It just, I mean, time wise, I'll limit the digging into it too much. But that is the other thing is sometimes when you start sharing the knowledge, there's that initial, but it's sort of like books being translated into a universal, like a language across the world, so everybody can have access to them. Yes, there's initial, well, what are we reading? But then once you read it, now with technology, if you're moving towards a future where people can access it, all of a sudden just regular people have more knowledge about what's like the simple example I used of buying a house. How many people have bought a house and 2 years later they realize someone's been piecing stuff together behind the wall and they got essentially scammed. You
Oh,
can,
absolutely.
those kind of things. Those are real things that happen, and I mean, that really affects people's lives. So,
Oh, absolutely. And that's one thing, in terms of that availability of useful data information.
yeah.
I think I do have to say the United States is one of the best places in the world, especially when it comes to the geographic, geospatial type of data information.
Mm,
And thanks to the work of agencies like USGS, US Forest Service, NOAA, and all that, we have so much great geospatial data sets
mm,
out there free for everybody and anybody to use. I used to single-handedly mapped the entire U.S. Pacific region when I worked for the Forest Service. The land cover data, that's all freely available to anybody and everybody.
wow.
And that, many do not realize what others have been able to do based on those free data. But in other countries, as we all know, this kind of data sets are considered national security. They're not available. So that, that kind of uh, you know, barriers set up in those countries are not helping. And for us
Right.
in the US, we're very lucky and we have access to all that data and then ties this to the culture in Silicon Valley, that openness,
That
that idea
openness. Yeah.
sharing. And that's actually, brings it back to where we started, is why, that's the key reason why when it comes, especially comes to the new technology, particularly in the Valley here, we are quite a bit ahead of other places.
Leo, I can guarantee you and I could talk for another hour, and it wouldn't. There'd be no difficulty. I live in a world where I understand half the things that I've got around me that I'm managing, and then the other half of my life is essentially trying to find things I don't understand. I've done some episodes similar to this before, but never had a chance to really dig in as much as we got to today. So, I really appreciate your time. I hope you enjoyed it. It was a ton of fun doing this interview. So, I really do appreciate you coming on.
Hey, it's my pleasure. Like I said, I've been a fan and appreciate the opportunity to be here and maybe I look forward to our next conversation.
Yes, I hope so. Okay, thank you, Leo, and thank you everybody for watching. We are going to have links, obviously, to Inertial and Inertial Labs. We'll have links to them. They've got a YouTube channel. They've got a LinkedIn channel. We'll put a direct link to Leo as well if you want to connect with him directly. Yeah, amazing information. I hope you enjoyed it. Thank you for watching. Please keep suggesting guests. Please subscribe if you haven't already, and we will see you on the next episode of The Construction Show.